we're going to finish section 4.5, which is the intermediate value theorem and discussion of upper and lower bounds. First. Okay, so the intermediate value theorem says you have some polynomial function, which is what we've been dealing with, bouncing, crossing, end behavior, etc. And you have a value of a and b, where a is less than b. If f and of a and the f of b are opposite signs, meaning one's greater than 0 and one is less than 0, then there has to be a 0 between a and b, the values of a and b. So think about this. If you have a function and you have your x-axis and the f of a is above and the f of b is below, that means it has to cross the x-axis at least one point. So, for example, you're given the f of x is equal to 2x to the fourth plus x squared minus 1. And I want to know, is there a 0 in the interval between -1 and 0? How am I going to check? I'm going to plug in the f of -1, the f of -1, and you can do it by straight substitution or by synthetic substitution. That doesn't matter. That's going to be 2 plus 1, which is 3, minus 1, which is 2. Plug in the f of 0. That's going to be 2 times 0 to the fourth plus 0 squared minus 1, which I believe is -1. So -1 is less than 0, a is less than b, and you get alternating signs. 2 is positive, -1 is obviously negative, so the answer is yes. There is a 0, a solution, a real solution on the interval from -1 to 0. Okay. The upper bound and lower bound definitions, I do it a little bit different than the book does. But I'm just going to pause here and give you an opportunity to write it down. So your book talks about M. I don't like M because we've been using C so much. So you synthetic divide by some constant. You know, you put the number off to the side, whatever. And if that results in all positive values or a combination with 0, C is an upper bound. I'll do an example. It'll make a lot more sense. And when you divide by some constant and it results in alternating plus, minus, etc., then C is considered a lower bound. And again, we will do an example of that in just a minute. Let's start with all the definitions and get it out of the way. Lastly, a polynomial of odd degree has at least one real 0. Okay, so I'm going to give us a function, and we're going to go through the whole thing with Descartes and this whole thing with upper bounds and lower bounds. So I'm going to give you the function x to the fourth minus 5x squared minus 36. Before I do all of Descartes and everything else, you can solve this problem without having to do any synthetic substitution at all. You can factor this. So I'm going to show you that first, but then we are going to do the whole Descartes thing. Which way do I have to do it, Ms. Abiak? If you can factor, then by all means, you should factor it. This factors as x squared minus 9, x squared plus 4. If you know how to do it, great. If you don't, all right. So if I ask you to find the zeros, you would set this equal to 0, and you would say x squared minus 9 is 0. This is the difference of two squares, x plus 3, x minus 3. So you get x equals 3, negative 3. X squared plus 4 equals 0. This is going to be imaginary. X squared equals negative 4. Root, get plus or minus 2i. 4 solutions, degree is 4, 4 solutions, 1, 2, positive 2i, negative 2i. Okay, so that being said, I will ask you though to evaluate the function. That means you need to be able to tell me Descartes, how many positive zeros, how many negative zeros, etc. So going back to the function, regardless if you factor it or not, you need to be able to analyze the function. So the first thing I will ask you is how many real solutions? And the answer to that will be at most 4. Degree matches at most the number of real solutions. Okay, I will ask you what are the potential rational zeros? So if there are rational zeros, they have to come from the P over Q list. That's the factors of P, which in this case is 36. I know it says minus 36, that's taken care of in the plus or minus sign, over the factors of 1, which is just 1. So the potential rational zeros are plus or minus 1, 2, 3, 4, 6, 12, 18, 36. Oy. Okay, so that comes from P over Q. Descartes. So Descartes is going to be super helpful when we're talking about how many positive and how many negative zeros. So I'm just going to rewrite the function to do the positive zeros. So 4 minus 5x squared minus 36. Okay, so Descartes' rule of signs, positive x, there is 1 sign change from x to the 4th to negative 5x squared, which means there is 1 positive real zero. It might be irrational. It might be the square root of 2. It might be 3 plus or minus the square root of 29 over 7. The f of negative x is x to the 4th minus 5x squared minus 36. It's actually the same as the function, which tells you that this is even. The f of x is the same as the f of negative x. This is an even function. 1 sign change, which means there is 1 negative real zero. Okay, I know that I did the problem up above, but I do want to caution you that if it's a rational zero, it comes from this list, okay? Potential, it doesn't mean that it has to be on this list. So one thing to keep in mind is if you were using the quadratic formula to solve, so whatever, you end up getting x equals 1 plus or minus the square root of 17 over 3. A positive real and a negative real. That is possible. It's just saying that if the answer is rational, if the answer is rational, it comes from here. Okay, so if I ask you to analyze the function, boom, there we go. But I might also ask you to find the upper bound and the lower bound. So what does that look like? All right. Synthetic divide. I'm going to start with 1. We always start with 1. It's the easiest value to plug in. So I have, don't forget your zeros, 1x to the 4th, 0x cubed, negative 5x squared, 0x, negative 36. And I already know that I'm writing too big. Okay. Bring down the 1, 1, 1, 1, -4. Okay, I can tell you right now that this is not an upper bound. 1 is positive, 1 is positive, -4 is negative. So this means that the positive real zero must be greater than 1. Okay, so not only it's not a 0 because the remainder is not 0. So what the upper bound, I don't think it's a theorem, but if I'm going to be an upper bound, all of the quote unquote coefficients answer, your book calls it the third line, which confused me. Line 1, line 2, line 3. These have to all be positive or 0 if it's going to be an upper bound, which means my positive real 0 has to be more than 1. Let's try 2. Bring down the 1. 1 times 2 is 2. Add, you get 2. Great. 2 times 2 is 4. Add, you get -1. Ugh. This is 2 is not the upper bound. My positive real 0 must be greater than 2. I'm going to keep going because it might actually be the 0 itself, which of course it's not. -1, -2, -1, -2, -40. These are not all positive or a combination of positive and 0. Now I'm going to try 3. 1, 0, -5, 0, -36. Bring down the 1. 3, 3, 9, 4. Oh, this is good. 4 times 3 is 12. This is good. 12 times 3 is 36. Not only is it a 0, but 1, 3, 4, 12, 0, they're all positive. They're a combination of positive and 0. Therefore, 3 is an upper bound. Three is an upper bound. So there's a lot going on here. Well, how many positive answers can we have? We said there was 1 positive real 0. We got that it was 3. So I'm going to stop because of Descartes. However, let's say that there were 4. I'm just making this up. Let's say there were 4 positive real zeros. I would stop at 3 because all the coefficients here are positive. By the upper bound theorem, 3 is the highest 0 that there is. So I wouldn't bother plugging in anything higher than 3. Like I would try maybe 3 as a bounce, so maybe 3 would work again. But this tells you you can stop at 3 because 4, 6, 12, 18, 36 don't work. And of course, in this example, they don't work because there was supposed to be 1 positive and we found it. And we did the problem up here and we knew that as well. So now I'm going to do the negatives. And I wrote too big. Okay, I'm actually going to use, no, I'm going to go back to what we started with. So I'm going to say -1. And for the negatives, I want to alternate positive, negative, or with 0. 1, negative. Okay, this is good. Alternating. -1 times 1 is 1. Oh, not alternating. So I know that my lowest 0 is lower than -1. That's what that means by the lower bound theorem. They need to alternate, plus, minus, plus, minus. This is -4, -40. Didn't save myself much room. So not only is -1 not a 0, it's not a lower bound. So then you're going to do the same thing with -2. I think you know how to synthetic divide. Then you get to -3. And for -3, you get 1, -3, 9, 4, -12, 36, 0. They alternate, positive, negative, positive, negative. So not only is it a 0, -3 is a lower bound. All of my real solutions must lie between 3 and -3. All of your solutions must lie between 3 and -3. Okay, to solve it from here, this is x cubed plus 3x squared plus 4x plus 12. If you use the function, you would get, here you would get x cubed minus 3x squared plus 4x minus 12. It ends up working out the same. Use grouping. Either way, either function is going to give you the same answer. Group, you get x plus 3, x squared plus 4, and then you would solve it like I did up here, x squared plus 4. Note, one positive real 0, we found it, it was 3. One negative real 0, we found it, it was -3, which tells you that the 2 remaining zeros must be imaginary.